Welcome to Ask and Learn.
Here we have an equation of motion for a particle which is moving with simple harmonic motion. Simple harmonic motion implies that it starts at an equilibrium point, it travels a distance of x away from the equilibrium point, at which point it changes direction, travels back through the equilibrium to a distance of x on the other side, and then back to the equilibrium. And that is a complete oscillation of the particle. What we can say is that at the point that the displacement, so x, is at a maximum, the acceleration is also at a maximum because it's acting to change the direction of the particle and pull it back towards the equilibrium. When the equilibrium is zero, there is no acceleration acting, but the velocity of the particle is at a maximum. So when x equals zero, the velocity is maximum and the acceleration is zero. So the first part of this question wants us to work out at which point the velocity first reaches zero. So from this, we know that that is when the displacement is at a maximum, so at this point in the motion. So what we want to do is see at which point this expression here for the displacement is at a maximum. And we know that is when sine 20t plus pi over 3 is equal to 1. So what we can say is that sine 20t plus pi over 3 is equal to 1. So now what we can say is that 20t plus pi over 3 is equal to arc sine 1, which is equal to pi over 2. Rearranging this by subtracting pi over 3 from pi over 2 and dividing by 20, we obtain that the first time, so t, when the velocity reaches 0, is pi over 120 seconds. The second part of this question wants us to work out at which point the acceleration reaches 0 for the first time. So we know that the acceleration is the rate of change of the velocity, and the velocity is the rate of change of position. So what we need to do is differentiate the expression for the position twice to obtain d squared x by dt squared, so the acceleration. So differentiating this once, we get that dx by dt, and then remembering to use the chain rule, so 20 times 5, so 100, cos 20t plus pi over 3 is equal to the velocity. But remembering that we want the acceleration, this is another derivative of this, so the rate of change of velocity, so dx squared by dt squared, and remembering again the chain rule, so 100 times 20, so 2000. Remembering that cosine differentiates to negative sign, so we need to include the negative here. Sine 20t plus pi over 3 is equal to the acceleration. So we want a to equal 0, so what we need to do is say that sine 20t plus pi over 3 is equal to 0. So if we draw a rough sketch of the sine graph, we can see that it follows a period like this, where a complete oscillation is 2 pi, and the first point that it reaches 0 is at pi. So what we can say is that 20t plus pi over 3 is equal to pi. So again, rearranging this to obtain t, by subtracting pi over 3 from pi and dividing by 20, we get that t is equal to pi over 30 seconds. And as stated before, in simple harmonic motion, when the acceleration is at a maximum, the velocity is at a minimum of 0, and when the velocity is at a maximum, the acceleration is 0. So when a is max, v is 0, and when v is max, a is 0. So the final part of this question wants us to state when the speed will be at a maximum from the first time. So we've just worked out when the acceleration is going to be 0 at a time of t is pi on 30 seconds, when the acceleration is 0, the speed is at a maximum. So we can say that the Vmax, so the maximum speed or velocity in this case, is equal to the same time that the acceleration is 0, which is pi over 30 seconds again.